Hello, everyone. Thank you all for joining today's webinar. My name is Carlton Brewer, and I will be your moderator for today. I want to start by thanking everyone for joining us. We have a great afternoon planned, and our speakers are looking forward to sharing their expertise with you all. Before I introduce today's speakers and who 3DS is, I want to mention that this session is being recorded, and the replay link will be sent to all attendees. Please feel free to reference the recording and share it with your colleagues if they're interested. Just so you're aware, attendees' phone lines are muted. So if you have any questions during the webinar, please submit them via the question window located in the GoToWebinar control panel. We'll address them at the end of this presentation during our Q&A session. Finally, if you could please take a moment at the end of today's event to give us feedback regarding the information presented today, and we will assist us in providing additional webinars on topics relevant to your industry. Next slide. Today we have two speakers. We have Christina Luquidi and Matt Blackman. Christina is our senior industry process expert, and Matt is from Hecla Mining Company, and he's a 25-year engineer in the mining engineer industry. Next slide. And today the table of contents, how we're gonna go through this webinar is, we're going to introduce who Dassault System is, traditional versus parametric mine designing on a 3D experience platform, and then do a technical solution demonstration, and then end with the Hecla mining story, user story. Next slide. All right, at Dassault, we're a purpose-driven company with one goal: to make the world more sustainable. With about 20,000 passionate people from 140 nationalities across the globe and 270 customers worldwide, we're able to create large impact by partnering with companies like Hecla Mining. Hecla Mining has three major objectives: to have a small footprint, large community benefit, and safety. Hecla has also become the U.S. largest silver producer, aligning with their mission to create long-term value from mining silver, gold, and associated base metals. Next slide. At 3DS, we have a proven track record. From the start of 3D design in 1981, we have disrupted the industry. 10 years later, we partnered with Boeing, creating a 777 project completely in 3D, marking the first time an entire aircraft was created in 3D without a physical mock-up. We didn't stop there. In 1999, we partnered with Toyota and created the 3D project life management. With this, the entire life cycle of the product development can now take place in 3D. We knew we could do better. There was a better way to manage data and manage change on a larger scale. So we created the 3D experience, a digital platform now connecting people, ideas, data, and solutions to help companies create differential experiences for their clients. Now that you've heard about 3DS, I would like to turn it over to Matt and Christina.
Thanks, Carlton. I'm going to start out today talking about the traditional versus parametric mine design. So this has kind of been a little passion of mine since transitioning into my new role from caving. So what I would like to do is just kind of take you through most of this, and then we'll end up with Hecla's use case that we've worked together through the past year. So with traditional mine design, a lot of us are probably familiar with it. We've started as mine planners and mining engineers. It's generally a time-consuming process. You will use traditional CAD or line work tools. If any changes or iterations have to happen to the design, the user usually has to go back and restart from the beginning. So usually the end result of this results in either weeks or months manual work for the engineer. So then when I started thinking about parametric design, I was thinking, how can we do this differently? So can we automate this? So here I'll take some sort of like input, whether it's a geology solid or ore body, and we'll create these templates. So it could be the level access or ramp design or stopes or ring designs. And we can connect these all through templates, through parameters, and through scripting. So here is what we kind of end up with at the very end. So we'll see this is the parametric model. So any change that's done to a parameter, automatically updates the model. So not only are we employing traditional CAD, but we're also automating this through scripting and through the templates. So anytime a change happens locally, it's actually going to be cascaded globally through the entire mine design. So this allows us to do a quick analysis of different scenarios, different design criteria, based off the inputs and parameters that we want to use at that moment. So this reduces our design cycle time. So it goes from what was once weeks or months down to minutes or hours. So what are the benefits of automation? So in traditional design, it's kind of the industry standard throughout the mining industry. There's a large talent pool of engineers and mining planners that come through university with this design experience. But the cons are really that it's time consuming. It's a manual process. If any change happens, a large portion of the design has to be redone. So in my case, when I was a mine planner, I had an engineer come to me and tell me that the vent raises needed to be 75 degrees rather than 80 degrees. This resulted in like me spending another month in updating the design. So it really doesn't allow for this quick analysis of multiple scenarios. So if we shift to the parametric design, the pros are the increase in speed and accuracy. So once you have the model built, if you want to change or update any parameters, you can do that, and it's going to quickly create a new mine design for you. The time savings also helps with, in mining industry, we're all very resource constrained. So we don't have a lot of people to do the job. So instead of having an engineer or planner physically have to do the entire mine design, they can be freed up to do other important tasks. The other thing that I really think is important here is that the design knowledge is captured in the templates instead of the employees. Again, with that resource constraint of humans and people and knowledge, as people leave the company or if they're promoted within the company, that expertise is lost and sometimes it's not going to be passed down. So what this kind of ensures is that the design is going to be done correctly, accurately, and so it's going to be a more safer, accurate design in the end. I would say the one con is that there's a time to build the model. So there's investment or time you have to put up front, which in the end you'll save, but it is, whether you want to spend that time now or later throughout the life of the mine. So I think the one con is just the time to build the model. So let's go on to mine design on the 3D Experience platform. So I think first we need to talk about what the 3D Experience platform is. So in general, it's just a collaborative environment that connects all the users together. So we have data storage within the cloud, we can talk within this platform, and it also gives us access to a catalog of different applications. So whether it's for mine design or for simulation, we have all these different applications we can use. And depending on what the user's interest, so if it's a manager, he might have a different role or different need to visualize data. So there's different roles that are suited for different people. So an engineer might have a different set of applications given to them than a manager would. So I'm just going to show this quick little video, just kind of an introduction so you can see what it looks like. So we start off with our dashboards. Dashboards is just like where you can centralize your data, how you want to view it. So you can see we have different playing options so you can visualize the data. You can link to all the storage. We have different task, collaborative project management aspects associated with the platform as well. And I think the most useful part is actually this is our communities. So here we can talk, ask questions. I think the most important part is the wiki pages. So here we can document all our processes, have everything in a centralized location. So we're taking things out of emails and into a community that is very transparent and visible to everyone. On the side, we also have all our applications. So here I'm just opening up the civil design application, and I can look for any of my projects. And it's just going to load up and bring up any projects that are currently stored on the cloud. So once it's open, I can start looking at it, manipulating, playing with it in the various applications that I have. So this is my model that I created. You can see at the bottom, I have all the applications. So these are probably closer to like a traditional CAD-based applications. But if you go up to the compass, we can change it to different apps. So whether it's to check the volumes or to modify terrain, it all can be done in one location. The benefits of this is we're not having to export and import data if we want to go check something else or do something in a different package. everything stays in one place and you just have to change the application you're using. So what is our typical workflow when we're talking mine design? And so how we interpreted it, especially with this parametric design, is we typically follow this 4-step process. We don't always have to follow the same 4 steps. Sometimes we'll jump ahead, all that, but the main part is that generally we'll start off by importing or validating the data that's coming in. So perhaps you're bringing in geological solids, perhaps you're bringing in an ore body, stope data, anything like that, anything that you're going to need as you move forward. The next step is building the parametric model. So this is kind of when we go in and we create all the templates. We kind of do all our scripting, add all parameters, everything like that. So once we get to the 3rd step, that's when we actually can generate our design. So everything is kind of linked up, the templates all hook into each other, and we're able to generate a design, change parameters, and it's going to update automatically. Then we move on to the 4th step. This is when we can simulate and analyze. So here, instead of me physically changing the parameters, what I can do is I can get the program to actually do that for me, and it's going to actually output all the different results that I'm looking for. So if it's the length, the cost, or whatever I'm concerned about, I can actually allow it to do it for me. The nice part of this process is, say, like with the Hecla example, once we've done this first 3 steps together, we no longer have to go back and do the 2nd step. So we're in a place right now with Hecla that if they were just to give us the new inputs that we need for our templates, then we can just generate the design. So instead of taking the full, project length to do it, we can, instead of the 2 weeks it takes for them to do it, it would take us basically a day to do it. So it's just we get to expedite the process. So I'll actually show you some of the models that I've built or we've built. So the first one I'm going to start with is a long-haul stoping mine. So the idea behind this video and this project was the clients wanted to look at electrification of the mine, and they're not really sure, with the different equipment, what the drift sizes will need to be, what is the ramp gradient, what are the different offsets we'll need for different things. So they wanted to be able to quickly change anything and update the whole mine. So what you're seeing here is as we update or change any of the parameters, the entire design is going to fully update. So there's essentially about 5 templates that are working here. There's a template for the ore access drives. There's a template for the level accesses to come off. There's a template for the ramp gradients as well. And then there's 2 more templates there's an exhaust and charging station template and also an escape way template. So as you see, like here, I'm updating the level spacing. So it's going to update first all the ore drives. It's then going to go back, update all the level accesses. Then it's going to go back, update the charging station and the escape ways. So instead of, a user, in my previous jobs, I would have had to do that by myself. That would have probably taken a month to do. It now takes about maybe a minute or so to do. So it's really radically changing how we're able to evaluate and approach the design. The other thing that's kind of good about it as well is we're not only able to have input parameters, we can also have these output parameters. So these are values that we're calculating that we want to come out of the model. So any changes to the model, it's automatically going to update those parameters. So here I changed the grade of the decline from -14 to -12, and it's going to update everything, and the total length of all the development changes from 15,000 to 16,000. So it doesn't have to be length, you could add cost into that, anything that you're really concerned of looking. You can see it's controlled by a series of scripts, and then it just has several outputs. So we have our 3D model and center lines that are really the outputs from this model, but it really depends on what you're looking for and what you want to see. So that's this first video. The next video is, or that first concept of how we actually make the models and how we can link all the parameters. In the next video, I want to show you the next kind of portion of it. So it's a simulation and analysis portion. So once we have everything linked up in the parameters and it's automatically updating, what we can do is we can add it to a design of experiment. And so here, what I can do is I can link up all the parameters as my input. So I'm just going to here grab the project. This is from a sub-level caving project I did before. But what we can do is we can pick all the parameters we're concerned about viewing, and then we're going to add them to the design of experiment. When we're in the design of experiment, we can change basically the number of iterations, how many different parameters we want to change, or the types of runs we want to do, number of runs. And we can select the different parameters we want to change. So here we have lower and upper ranges for all the parameters we want to set. And essentially it creates this design matrix where we get to select, or where it selects all the parameter values, and then we'll have our responses. So here I was just looking at what is going to be the total length of everything. So once that's set up, it's going to go and once I hit run, it's going to change all the parameters in the actual mine design that I've made. So you can see it's just going through, changing the parameters, and it's going to give me all the results. Some results or some parameter combinations won't work, and we'll see that they're infeasible, and that's fine. We'll just kind of realize that we can't use those parameters moving forward. And then once we have everything run, we get to look at it in results analytics. So basically, this is going to take all the data that we use going into the simulation, the inputs and the outputs, and we're allowed to view it all at once. This is just allowing us to see the general statistics of everything that we put in. And then here's kind of the critical stage of where we get to define the ranking. So here, right now I just have one ranking for total length, but you could change it if you had different metal prices or however you want to rank the runs. So we get a calculated rank for everything, and then we can kind of narrow down to what we think are the best runs. We can change any parameters and view any of them, and kind of use the filters to dynamically look at the results that we're seeing. Anything that we kind of like, we can add to our basket, compare it, and these might be our favorite 3 options. And once we have these options, we can just look at them here. Here we would be able to dynamically change, like if we had multiple, not just total length, if we had perhaps the price of copper, we can see how that might influence the rank and dynamically compare them like that. So it's a really interesting tool to be able to kind of understand what we're doing in the simulation. So far I've been talking a lot about open pit, about underground, but and in the future we're also going to talk more about underground, but I wanted to bring in a little bit of the open pit. So this is just kind of a preview of, we have new roles coming up in the open pit space as well. So it's similar to what you've seen before with the models that I've created, but in this case, instead of it being someone creating models and scripts, this is actually kind of an out-of-the-box solution that will be easier for anyone to kind of pick up and just use. It's very similar to our most mining software in the inputs that we have into it. So you can change, your berm, your bench widths, you can, bench heights are, you can change the ramp gradient, all those kind of things, all the basic parameters. The only main difference is that this is now parametric. So anytime you want to change something on mass, generally in those programs, you have to go back and you have to redesign the whole pit. Here, if I want to do something, if I want to change the berm width, I just go in, I change that in my file, and it's just going to update the whole mine design for you, considering all the initial parameters that you've already put into it. So it's just reducing the time that it takes to create these designs. There's also the other traditional goodies that you would find in most GMPs, which allows us to control things based on regions. So we can have different angles and berm widths based on region. So it has all those little goodies tied into it too. So that's just kind of a quick overview of the new rules that are coming as well within the Geovia space. So then if we move on to Hecla and what we've been doing, I'll just pass it over perhaps to Matt for a little bit to talk about him and his company.
Sure. So I'd be remiss if we didn't at least talk about being one of the oldest precious metals companies in North America. Currently, we've got 3 operating mines in Quebec, Greens Creek up in Alaska, and then the Lucky Friday mine in Idaho. If you want to go to the next slide. In particular, we're looking at the Lucky Friday, which is it produces about 3.5 million ounces of silver. We also produce lead and zinc from that deposit. And that mine has been running since 1942 with a couple of changes over the years. We operate at a depth of about 10,000 feet below the surface, which adds a lot of complexity to the model. It's engineering, where are we going to mine? Then the ambient rock temperatures are, plus 100 degrees, so they have cooling issues to deal with. We have rock bursting potential. The ground conditions are difficult. And then there's a big push internally on how do we turn this historic asset into something that's profitable and actually turning on making some money. So we've got a lot of work going on to improve efficiency in the operations, the engineering, and then how do we optimize and prove that we have now made a substantial difference in the operation and the engineering. So go to the next slide. In particular, we're looking at a depth from or a total extent of the ore body that we're looking at is something over 4,000 feet vertically and say 2,000 feet along strike. That becomes a really large area to have to design and work around, working with all of the legacy issues there, and then changing to a new mining method. It takes a lot of engineering horsepower, and we don't have that on there. Typically what we end up doing, or what most mining companies end up doing, is you do an annual update to your long range strategic plan, and you don't do many iterations on it. So it's just a single update. You never know where you are on that optimization curve. We need to be able to quickly evaluate different design permutations and just see what the effects are. If we do this, what does that do? And so that's when we turn to Dassault for the assistance.
Yeah, so around 2020, we started having discussions between Hecla and DS surrounding the automating the mine design. And we created several different prototypes, but we landed on basically what Matt was just explaining, that they wanted our first proof of concept to really cement, I guess, our services moving forward together, was to try and automate the mine design so we could rapidly evaluate different designs, send it directly to MineShed. So here we wanted to change the number of spirals, or perhaps the spacing between spirals, or perhaps the number of accesses for the slot per ramp segment. So we created a quick prototype to do that. So I'll just show a video of that as well. So essentially what is going on here is we're able to change all those parameters. So the distance between the ramps, the number of ramp spirals, and once the code actually updates the design, it's going to actually export a string file that we can just update in MineShed. It's exporting everything with the proper heading names, with all the right directions, so that it's going to make starting over in MineShed or continuing in MineShed or any scheduling software a lot easier moving forward. So once we were happy with that proof of concept and we were kind of moving in the same page or moving in the same direction, we kind of talked about how we wanted to actually create the template for them. So there's two main inputs. It's going to be their production, SURPAC Stope Optimizer Excel file that they create, and a reference surface. And then we take that and ingest that, and we've created a template that automates all the mine design for it. So these are the primary input sources. So we're just going to see the main keys that we're going to get from it is going to be the floor elevation and also an offset point. We also get all the ramp names, how many cuts are involved in it. So this is kind of what's feeding the template, and the surface is what's giving us our different intersection points.
Yeah, so if I just jump in there really quick, the important bit for, I guess, that we saw as a value there's this spreadsheet or this table was data that we were already using to control our stope optimizer shape generation. So what we're doing is just leveraging that spreadsheet or that amount of data and adding a few things to make the parametric design work. So we're not creating something fresh and making a new piece of work. We're just adding a couple extra columns to this existing spreadsheet.
Yep. So what the current process flow looks like is, so Hecla or Matt will create these reference surface and update the Excel spreadsheet for us based on what they're using in SURPAC Stope Optimizer. We take that in, and all we need to do is we need to bring in the data, update any file paths, and then we have to generate the actual mine design centerline. So this is the main piece of work that we've worked on in this past year with them. So creating all the slot accesses. we kind of went with the slot axis because they are the most time-consuming part of the design. Hopefully we will expand out in future iterations to include more things like the ramp or attachments to existing infrastructures. And then we also feed that back into, we export the central lines to a string file so it can be fed into their scheduling software. And we pass that back to them and they're able to create their Mindshed schedule or their schedule. So at this point, because we've created this template, the design process goes down from perhaps what was weeks before into essentially a day. So here we're just updating, all we need to do is import the new surfaces, update any of the file paths. And then here, this is the actual generation of the template. So the template, as we bring it in, we have different controls for it. So essentially what it's going to do is it's going to reference the spreadsheet. It's going to create these points along the reference surface. And from that, it's going to use these controls to kind of finalize the template. So the distance off the slot setback, where the gradient that it's coming back from, and basically its final point. So this point here, we can then link into any further development or template as we expand them. Our last step in the process that we do is we just have a script that exports it to Mindshed or into any file, any string file or anything that we want. The crucial part about this is that it's exporting with the proper names, the proper profiles, anything like that. It's also exporting in the way that the developments would be scheduled. So everything's cut up properly. So as it goes into Mindshed, it's going to be the proper sequencing is just going to happen automatically as well. So I'll show a quick video of it in action. So those are the stopes that we start off with, and you're going to see that the reference surface comes in. And so this is the stuff that is given to us from Hecla.
And that surface just represents the contact surface where the development needs to intersect with the stopes.
And so this is the Excel file that we'll also get. So the two main important parts is going to be the elevation and the stope section, so the midline, so where it's offset from the origin. And we just get to run the scripts. So what you're going to see in here first is it's going to create all the point intersections. And then it's going to go back and it's going to create all the development lines coming off that. So you'll start to see all the development coming off. And after that, it's going to create our double slots. So the double slots is just when we have basically a single ramp accessing two sets of cuts. And it's going to finalize all the development within that. So once that script is run, we just have to run our next script, which is to actually generate the Mindshed file or the string file. So it's just going to export that, and you can see that we now have a file that has all the different naming convention, everything that we would need for it. So then we're able to pass it on to Matt and to Hecla, and they get to bring it into Mindshed and do all their scheduling from it. So just as a kind of a summary of what we've done, I think the key portion between it is how we've been able to work and do design workshops and understand what is the process that they need for their templates. So the key thing when doing any of this parametric design is to understand what you actually want the templates to do. With any computer program, you need to be able to explicitly say, it needs to be offset this much, it needs to do so on and so far. So we've worked together to really define what the templates need to look like. And so we've drastically, in doing that, reduced their design time from weeks to hours. So hopefully in the future we'll work together and we'll continue the expansion of the templates to include all the definition of the existing infrastructure and ramps. And yeah, I don't know if you have anything else, Matt, that you would like to add?
Yeah, I think just to highlight, there's the little white bits there. We seem to be missing some ramps. What we find is that internally, as a mining company, we didn't always have hard and fast rules for what those parameters should be. So it's not that we couldn't do them or shouldn't have done them. It's that internally we didn't necessarily have those parameters hardwired. So what we focused on was the part that's the most challenging for us, which is lining up where those slots and the cuts are. So that's the most amount of work. Let's focus that. That's the easiest one to define what the parameters look for like, and let's see what the benefits look like. And I think we've achieved that. And then the other bit would be this partnership. This is a new way of looking at design for us. And so partnering with somebody like DS to provide someone who can sit in the seat and drive the software for us, that takes some of the learning curve away from us and get somebody to push the buttons for us, which is a big help. So like I said, I think this was a success for what we're trying to do, and we're pretty happy with what's happened. So.
Yeah, I think that's why I've been so impressed with the software as being a mine planner before and having to go back and iterate and do all that. I just find it so powerful in what we're able to do in such a quick amount of time. So it's cool. It's just that we really need to work together in the future to design, how we want to design it and what are kind of the outputs that we need. But as soon as we have that, we can kind of create and make anything through the automation. So it's a really cool piece of technology that we get to work with. So with that said, if there's any questions or anything that we would like to discuss at this point, I guess we can open up the floor for that.
Okay, thank you, Matt and Christina. So we got a few questions already. I'm gonna start with what are the biggest challenges in the project? And I think either one can answer that one.
I would say from a client side of things, first it was just trying to define, and a lot of our design processes are, I don't want to say tribal, but they're stored within the organization, and you just design. It's intuitive, and trying to explicitly make a formula that says to go from here to here, this is the geometric relationship between these objects. It was something we didn't have as a guideline at the moment. So it took a little while for us to assemble all that information. I think that's the biggest one for us.
Okay. Yeah, I think it's key in any program. You need to be able to clearly define the problem, and if you don't have that, it's hard to actually move forward. So I think it's weird because we're so used to just doing it and not having to explain ourselves. So it's an interesting switch.
It's really easy to take a Sharpie and draw on a piece of paper and draw a straight line from here to there. Writing the mathematical equation that connects those 2 points is a bit more of a challenge, and that's the difference, I think, is just historically in the mining industry.
Okay, great. I think this one is for you, Christina. If we provide the software with the drill hole data, can the software automatically develop the best mine to maximize the net present value?
I wouldn't say we're there at this point. Like we're able to, if we were able to, we could set up rules around the drilling. We could create the stopes from that. I think perhaps the MPV, we would have to do some sequencing and scheduling within that. It's a little bit past what we've done so far. I don't think it's out of the scope of what we should be able to do in the future. So it's just really defining what is the most important parts at this point. But there is, like from the drill holes, we definitely could create something parametric from that. We could analyze those stopes against a block model, certainly like that. The scheduling piece, we would have to figure out how to actually find the MPV for that. So that would take a little bit more complexity, but that's hopefully where we're heading. That's definitely what my interest is.
My first thought is that a CFO asked that question, hoping that the accountants can get rid of the engineers and the geologists and just push a button, have the computer tell them what the optimum is. I think the reality is the engineering and geology still has a place for that. Theoretically, we ought to be able to get from here to there, but there's a lot of intermediate steps and processes that would have to be defined, and even the word optimum MPV is a very subjective number, and I think you'd have to define what that means to you in order to make that work.
Okay. I have another question. Does 3DS have its own own so that it can use to create optimized stop shapes?
Shape. Does it have, I don't know if I can read the question.
Yeah.
It's the same Alfred Mining Systems engine that's used in all the mine plan. As far as I know, that's the industry leader. Surpac and Geovia are using the same product that the competitors are using. So it's not proprietary to 3DS. It's Alfred Mining Systems mineable shape optimizer engine.
Okay. Next question. Potential benefits. What are the potential benefits? And I think this one is probably to you, Matt.
For us specifically, we just looking at the slot accesses, those white lines that we were designing there, that amounts to something like 65,000 feet of development over the life of mine. You choose what your mining cost might be, but a number like $1,500 per foot is not an outrageous number. So now you're talking over $105 million just in that capital investment. If I could cut $10 million off of that, is that a savings? I suspect it is. So being able to optimize that and really assure yourself that you've done the best possible job in the design, you've got over $105 million at stake in just this one part of the mine. I suspect you're looking at dollars and cents, and being able to quickly turn around those, the design process, the engineering process has gone from being a CAD push button process to engineering analysis. Am I doing the right thing or the wrong thing?
Okay. Let me check to see if we have any more. And again, if you have any questions, please feel free to drop them in the question at the bottom of the go to meeting control panel. Okay, if we don't have any more questions, I see that we're almost out of time. So I'd like to thank the presenters, Matt and Christina, for sharing their time and expertise today. I'll also extend another big thank you to all the attendings. We hope that you found this session very informative, and we look forward to seeing you in other Dassault Systems events in the future. If you have any questions or wish to learn more about this topic, please reach out to Christina, see if her information is on the, it's right there at the, as you see on the screen, that's her information. Their contacts is on the screen. Additionally, research and web topics, as well as today's recording, will be sent to you via email. As a reminder, there will be a quick survey after the session ends, and when we value your feedback that you provide. Thank you for joining us today, and that concludes our webinar.